lesson, we discuss trigonometry. Trigonometry is a branch of math that focuses on triangles. A triangle has sides and angles. In trigonometry, we study the relationship between these sides and angles. Say we have a triangle with sides 3, 4, and 5. This is a right angle triangle. If I measure this angle, I'll find that it's 53 degrees. Now, let's double the size of the triangle. Now it's 8, 6, and 5. I mean 10. 8, 6, and 10. 8, 6, and 10. Angles will still be the same because of similarity. So that's 290 degrees. This is still 53 degrees. This is still 53 degrees. Now, let's compare the ratios of the sides. If I look at the side opposite the angle, and hypotenuse, which is the longest side, the ratio here is 4 to 5. If I look at the ratio here as well, the opposite to the hypotenuse, it's 8 to 10. Which simplifies to 4 to 5. Notice that the ratios are exactly the same, even though the triangles have different sizes. Since the angle is the same, the ratios ended up being the same. I can also look at the adjacent and hypotenuse, which is 3 to 5. I can also look at the adjacent and hypotenuse here, 6 to 10, which simplifies to 3 to 5. Then I can look at the opposite and at the adjacent. The ratio is 4 to 3. I can look at the opposite and adjacent, 8 to 6. 8 to 6, which simplifies to 4 to 3. So, all the ratios are the same regardless of the size of the triangles. This is the foundational idea of trigonometry. The ratios of any two sides relative to a specific angle will always be the same for a right angle triangle, regardless of how big that triangle is. In other words, what we're saying is that if you have an angle theta in a right angle triangle and you have the same angle theta in a bigger triangle, the ratio of the opposite to the hypotenuse will stay fixed for that specific angle, same as the ratio of the adjacent to the hypotenuse and the ratio of the opposite to the adjacent. Now, these ratios have names. The ratio of the opposite to the hypotenuse is called sine. The sine of theta is always going to be the opposite over the hypotenuse. The cosine of theta is always going to be the adjacent to the hypotenuse. And the tangent of theta, which is simplified as, which is written as tan theta, is always going to be the opposite over the adjacent. You can easily remember this with the common mnemonic, the common mnemonic, SOHCAHTOA. SOHCAHTOA. Yeah, where S is sine, and this tells you that sine is the opposite over the hypotenuse. C is cosine, and that tells you that cosine is adjacent over the hypotenuse. T is tangent, telling you that the tangent is the opposite over the adjacent.